everyone, we're going to evaluate the improper integral or state that it diverges. We're going from 0 to 9. We have 1 divided by cube root of x minus 1 dx. It has an infinite discontinuity at x equals 1. So, for example, we are going from 0 to 9, but it's discontinuous at 1. And then we're going from 1 to 9. So it's discontinuous at this interior point, x equals 1. Therefore, we're going to write this with part 3, write it as two separate integrals. And we're going to write it as the integral from 0 to 1 of x minus, I'm just rewriting this, to the negative 3 power, negative 1/3, sorry, negative 1/3 power dx. And then we're going to add the integral from 1 to 9 of x minus 1 to the negative 1/3 power dx. So these are the two that we have. And let's call this one integral 1, and this one is plus integral 2. So for integral 1, we're going to write this piece here equals, and I'm doing this, the first piece is going to be the limit as t approaches 1 from the left. So just keep this in mind. This one is integral 1, and then we're adding the integral 2 here. That's what this one is. This is just adding these first two parts. All right, so once we have that, we're going to get, you change your, this is going to be 0 to t. We're changing the 1 to t. And then we have x minus 1, it's negative 1/3 power dx. All right, so we're going to evaluate this at the limit as t approaches 1 from the left. And then when you evaluate this, you're going to get 3 halves x minus 1 to the 2/3 power, and we're evaluating it from t to 0. All right, so for our evaluation, we're going to get the limit as t approaches 1 from the left, and it's do your substitution, 3 halves. Well, now we have t minus 1 to the 2/3 power, and then when you plug in the 0, you're going to get, this is going to be minus 3 halves, because this is going to equal 1. All right, now when you substitute in the 1 here, this is going to be 0. So we have 0 minus 3 halves. So this limit for integral 1 equals negative 3 halves. Now we have to do integral 2, which is this one. So we'll do that one. Then we're going to add them together. So we have, I'll write it again. Now we have from 1 to 9, and we're going from x minus 1 to the negative 1/3 power dx. Now do for integral 1, this one, it's this one right here. Or this is integral 2. Sorry. So this is integral 2 and this is integral 1. We already did integral 1. All right, so we're going to write the limit as t approaches 1 from the right. And then we're going to get 3 halves x minus 1 to the 2/3 power. But this time we're going from 9 to t, or t to 9. So substituting this in, we get the limit as t approaches 1 from the right. And then you substitute in your 9. You're going to get 8 to the 2/3 power. That's going to be times 3 halves. So that's going to be 3 halves. I should have did this. Cube root of 8 is 2 squared times 4. So that's going to be 6. This 2 goes into 4 2 times. All right, so you get 6 minus So we did the 9. Now let's do the t part. 3/2 t minus 1 to the 2/3 power. Now this part here is just going to go to 0. So for this is going to equal 6. That's integral 2. So now we're going to add integral 1 plus our integral 2, and that's going to be negative 3/2 plus 6, which is negative 3/2 plus 12/2, which equals 9/2. So that's your answer, and since it converges to a value, this is convergent. Thank you. Have a nice day. Bye-bye.